So we give specific names to the 25th percentile, the 50th percentile, and 75th percentile. We call these quartiles, and we denote them by Q1, Q2, and Q3. So Q1 is just another way of writing 25th percentile. Q2 is just another way of writing 50th percentile. And so I ask, well, what Q2 is the same thing as what measure of center? So Q2 is the 50th percentile. It's the spot where 50% of data lie below that data value. So in other words, 50% lie above it then, though, too. In other words, we're looking at the median. Q2 is the same thing as the median. Spot right smack dab in the middle of your data values. All right, a little more vocab for you. Interquartile range, or in other words, the IQR. This is the number equal to Q3 minus Q1. Or in other words, it's the distance between Q1 and Q3, which describes how spread out the most common data values are. So the most common data values, the most common data values, well, are ones between the 25th and 75th percentile. So if you subtract the 25th and 75th percentile from each other, that'll give you a rough measure of how spread out common data values are. So, and then I say the following. We can use the IQR, or in other words, interquartile range, to give criteria to declare whether a data value is an outlier. So, before, we just said, an outlier. It's an unusual data value. It's a data value that's way far away from all the other data values. Well, now we have some criteria to actually determine if something's an outlier. So we say that a data value is an outlier if the data value lies more than 1.5 times the IQR units above Q3, or the data value lies more than 1.5 times the IQR units below Q1. In other words, you got to compute Q3 plus 1.5 times the IQR, and you got to compute Q1 minus 1.5 times the IQR. If a data value lies above this number or below that number, then we'll say it's an outlier. So then I ask, does the sample of men's annual incomes in Corpus Christi have any outliers? Well, those incomes were on the other page. So what I did here is I have listed 20 incomes of men in Corpus Christi. I actually just made them up. That's fine. Now, in order to determine if there's an outlier, we got to find Q3 and we got to find Q1 in order to be able to use our formula. So we got to find the 75th percentile and 25th percentile. Now we could do it by hand. It's a bit of a pain. Our calculator can do it for us. So we got this entire list of data. Well, we want to put this list of data into our calculator. You can hit Stat, and then option 1 is Edit. Hit Enter on Edit. And now you can put 6 lists of data into your calculator at once. So if you scroll to the right, you'll see you can put up to 6 lists in. You can actually add more if you want. Anyway, all right. So I can say, all right, let's enter this data into list 1. So scroll down, and then you'd make your first data point 21. Hit Enter. Make your second data point 26. Hit Enter, etc. And move right on down the line. So you'd enter all these numbers into list 1. Now the numbers are in your calculator. Now if we're trying to find percentiles, it's important that our data is in order. Well, what if our data is in order? Like, let's say I messed up. Like in list 2 here, I entered in all the data, but I put the highest data value first. If we're trying to find percentiles, that's kind of annoying. Well, I can fix that. So if I hit second quit, I return to the home screen. So that second data list was giving me trouble. I accidentally entered it in reverse order, highest to lowest. I can fix that. I can hit Stat and move down to Sort A, stands for Sort Ascending, or sort a list in ascending order. Hit Enter. And now I want to sort list 2. So I'm going to hit second here, go down here to 2 to make list 2 appear, and then I'm going to hit Enter. And the calculator says done. Now if I go over to list 2, scroll over here, I see, oh, okay, great. Now my data values are listed in order. So yay. Great. I didn't have to like re-enter the data or sort it by hand or anything like that. Okay, anyway, we were trying to find the 25th percentile and the 75th percentile. Now we could do it by hand, but it's a big pain. If you hit Stat, go over to Calculate, and go down to one variable statistics and hit Enter. Your calculator will compute a whole bunch of helpful numbers for you. So I want to compute one variable statistics on list 2. So I'm going to hit second 2 here, make list 2 appear, hit Enter. And my calculator spits out a whole bunch of numbers. It says, okay, the mean of sample mean of the data is 37.05. The sum of the data is 741. Sum of the data values squared is that. The sample standard deviation of my data is 9.19. Your book uses a little, or your calculator uses a little bit different notation. It writes SX. We just write S. And then it says sigma sub x is this number, population standard deviation. Now, it's kind of weird that your calculator spits out this. We're pretty much never going to use this number. What your calculator is saying is if you entered every man in Corpus Christi's annual income, if you put all that in the calculator, you could find the exact population standard deviation. It would be this number. Well, your only time you'd use this number is if you had all the data for something in your calculator, the entire population data. Well, that's pretty much never going to happen, so we're pretty much never going to use this number. We're going to be using this number, the sample standard deviation. All right, our calculator is also telling us that n is 20. There's 20 data values. Now, if we scroll down, we see other helpful stuff. The minimum data value is $21,000. Q1, or 25th percentile, or first quartile, is $31,000. The median, or the 50th percentile, or Q2, is $37,000. Q3 is $41,500. The max income was $65,000. Aha! Well, now we have all the numbers we need to determine if something is an outlier. So, does the sample of men's annual incomes in Corpus Christi have any outliers? Well, we found out that Q3 was, let's see, $41,500. We found out that Q1 was $31,000. Okay, well, in order to be able to use our formula, we got to compute the IQR. Q3 minus Q1. So we got to do 41.5 minus 31. If we do that, we get 10.5. Okay? So, all right, now we're supposed to do Q3 plus 1.5 times the IQR. So we're supposed to do 41.5 plus 1.5 times 10.5. Crunch that number. And let's see. If you do that, you get 57.25. We're also supposed to do Q1 minus 1.5 times the IQR. So we have to do 40. Oh shoot, I messed up. One sec. So when we're computing. Oh, I'm sorry. No, I didn't mess up. All right. Q3 plus 1.5 times the IQR gives you 57.25.